Hi, welcome to Tag Arcade, and this is part 3 on how to do a button configuration screen. So let's go ahead and get started. So in order to detect the joystick axes, you do have to go into what is called the Input Manager. So to get there, we're going to click on Edit, go down to Project Settings, and then hit Input. By default, you're going to have a lot of different inputs, and these are the settings. So I'm going to say look at, let's see, what should I look at? I just want to look at horizontal here. So with this horizontal, you see that we're getting the joystick axes from the x-axis and get input from all joysticks. So I'm going to use this horizontal one with the gravity 0, dead zone 0.19, and sensitivity as 1 as the template for all the other ones. So for now, I'm just going to click 0 for within the axis size to clear everything and hit enter. Now I'm going to set up to 4, and we are going to set the first 4 to the names of the axes that we need for the event system. So within the event system, you do need a horizontal, vertical, submit, and cancel for this system to work. If you don't, you're going to get an error message every time you try to run something, or at least get like a warning. So let's go ahead and go to your inputs and make those changes. So the first one is going to be horizontal. The second one is going to be vertical. Next, we're going to do cancel. And finally, we're going to do submit. Okay. Now let's go ahead and label this so that we can read the joystick axis. So for the name, I'm going to say joystick 1. Move the mouse a little bit. Axis 1. So my gravity is going to be 0. My dead zone is going to be 0.19. And my sensitivity is going to be 1. Now under type, I want to get a joystick axis. And I'm going to read the x-axis. So as you can see, when you click on axes, it goes all the way down to the 28th axis. So unfortunately, you do have to do this 28 times if you want to get through all the different axes. And you have to do this for each player, which is sort of tedious and annoying. So for now, I'm just going to say the first one's going to be the x-axis, and I'm going to get motion from only joystick 1. So if this is 4 players, you have to do this 28 times for all axes, and then 4 times 4 for all the different players. So in this example, I'm just going to do it only player 1. So what I did is I changed the size to 14, and it's going to use my last configuration, and duplicate it all the way through. For time consideration, I'm only going to do 10 different axes. Okay, so I set the 10 different axes, and like I said, you could go ahead and do all 28 if you want. Okay, so joystick 1, axes 1 through 10. Next, we're going to go to our button info. So now, I'm going to add in some more variables into this. So first, we're going to do public string button name. So this will actually hold the name of the button that we want to use for when we do the joystick configuration. Next, we're going to do public string axes. So this variable will let us determine which axes we're going to look at. So like in our variable, we have, so if we go to our input, once again, axes is just simply going to be the name of whichever axis we're looking for. So in this case, it will be joystick 1, axis 1 through 10. So that's going to be what the axes variable is going to look at. Now we're going to look for something called axis state. So first we're going to determine what is axis state. So we're going to do public enum axis or axis state, and we're going to say none, positive, and negative. So what the point of the none, positive, and negative is to determine whether we're looking at the positive value of the x-axis or the negative value of the axis. So that way, if you're playing something like a flight control simulator, you'll know if you press down, it makes the aircraft go up, and if you press up, it makes the aircraft go down. So that's different than if you press up to go up and down to go down. So if you do it this way, you have the flexibility of inversing or changing around all the axes that you want. So hopefully that makes sense. So let's go ahead and go back, and we're going to name this public controls dot axis state, and I'll just call it axis state for simplicity. Okay, and we're going to go ahead and save. Next, we're going to go to our controls. Not our controls. We're going to go to our config screen, and we're going to now detect the different axes. So I'm just going to make a comment on the top, and the first comment is going to say detect button presses. And now we're going to detect our different axes or axis. Okay, so what are we going to do? Well, let's go ahead and create some variables. So int mac joystick equals 1. So the whole point of max joystick is how many joysticks are we going to try to go through to determine which button is pressed. So I'm just going to say max joystick equals 1 for now because I only created one player in the input manager. If you're going to create a 4-player game, you're going to want to change this number to 4. Okay. Now I'm going to say int max axis equals 10. So when you do add in all 28 axes, you're going to want to change this to 28 instead. For now, I'm going to say 10. Now we're going to create a for loop. So for int joystick equals 1, joystick less than or equal, oops, messing up with my arrows, max joystick, joystick plus plus. And I'm just going to make this lowercase actually, because it's convention that variables should be lowercase and classes should be starting with an uppercase letter. So once we do that, we're going to go through all our different axes. or axis. So int axis equals 1, axis less than or equal to, oops, equal, max axis, axis plus plus. Okay, so now we're gonna do input dot get axis, and since we called our different axes joystick 1 axis 1, joystick 1 axis 2, then we're gonna stick with that convention. So we're gonna say joystick plus joystick, oops, plus axis plus the variable axis. Okay. So this will pretty much go through joystick 1, axis 1, and in the next loop, it'll do joystick 1, axis 2, so on and so forth. And it's going to try to get the value of this axis. So we want to detect to see if this axis is going to be greater than 0.1. The whole point of detecting axis is the axis could be any number between 0 and 1. So if you move the analog stick about halfway in between, it's going to read a value of 0.5. So we're just going to give it a threshold of 0.1 to easily detect to see whether or not the user moved the joystick just a little bit, and if so, to bind that to the controls. So that's why I'm going to use a value of 0.1. Okay, so if it's greater than 0.1, okay, so if it's greater than 0.1, we want to bind our controls to the different axes. But before we bind the axis controls to our configuration screen, we actually have to do something at the top first. Since we created more variables, we have to set it to like the default values if we want to detect a button press. So what are some of the variables that we did? Well, our variables are going to be button name, string axis, and the axis state. So let's go ahead and start with the button name. So with the button name, we know that's going to hold the name of the button. So we're going to replace this top part with button name instead of key dot to string. So let's go ahead and do button name. And the same thing here. We're going to say, we're just going to copy this portion, and it's going to be for axis state, and button name. So I'm just going to say dot button name equals, and I know the button name is going to be this last one. So I'm just going to cut this, paste it, and I'm going to set that value to the button name. Next is going to be the axis. So if I map a button, the axis should just be blank or empty, because we're not reading any of the different axes. We're just going to be reading the button presses. And next, we're going to look at axis state. So if we're only looking at button presses, we don't really care whether or not the value is positive or negative. So we're simply going to set this to none. Okay, and I forgot my semicolon at the end, which is why this is highlighted red. So once we have that, we're going to copy all of this and we're gonna help use that to define what our axes are. So we're gonna paste it in. So now, if we're detecting axes, our key code should now be keycode.none, since we're not looking at a key code anymore. And now our axes name is actually going to be the name of this button input. So I'm just going to paste it in for the different axes. So if we're detecting an axis and the axis is greater than 0.1, we want this to say that this is a positive value. And we want the button name to be the name of the axis. But since we know that an axis can be positive or negative, we wanted to give it a little bit more description. So we're going to say plus, parentheses, plus, close parentheses, to let the user know that this is reading the positive value of the joystick. Once we're done, we're going to copy all of this, and we're going to do it a second time. This time, we're going to use this to define the negative values. And I guess I have my insert button on, so let's change that. So else if it is less than negative 0.1, this is going to be negative, so we're just going to change the axis state to negative. And for our button name, we're going to simply make this a negative as well. And we're going to hit save. Now, let's go ahead and turn on your controller. And we're going to go back to our configuration screen. So let's go ahead and go to configuration and hit play. So input axis horizontal is not set up. So why is that? I wonder if I misspelled horizontal by accident. So let's go ahead and go to project settings, input. And did I misspell horizontal? Oh, I guess I have a space in front of it. Oops. So let's go ahead and clear that. And let's go ahead and hit play. And that gets rid of that error message on the bottom left. So let's go ahead and press the key. Up is joystick 1, axis 2, negative. Down is the positive. Left, right, and NAS could be my other one, axis 5. So axis 5 is, up, I guess, up on the right analog stick. And there you have it. So if we go to control prototype, well, our car isn't quite moving because we are not actually detecting our axis when controlling it. But at least we have the configuration done. Okay. I guess if we hit play, you'll notice that nothing actually is saved as well. So I guess the first step we should do is save our new values. So let's go ahead and go back to our script and go to controls. Within the save configuration, we want to be able to save our different states. So the first thing we're going to do is save our axis information. So we're going to do player press dot set string, and this is going to be my axis plus action, and that's simply going to be my button action dot axis. Next, we need to get our axis state, whether it's none, positive, or negative. So we're going to do player press dot set int. Actually, since it's very similar to this, I'm going to hit copy and paste it. So I'm going to call this axis state, and I'm going to change the value to be access state as well. And the last thing is going to be the button name. So since the button name is just like set string, I'm just going to copy this and paste it down. And this is going to be button name. And I'm going to switch that to button name. Now to load the configuration, it's more or less going to be very similar to these three commands. So I'm going to copy those and paste it down here. So now instead of setting the value, I am going to make this equal to. So I'm going to move the variable to the front so that I could set the variable to what my player preferences are. So cut, paste, equals. And once again, cut, paste, equals. Now let's go ahead and clean this up. So get rid of things we don't need at the end. Oops. And now instead of setting a string, we just need to change it to get. Unfortunately, it's just changing one letter from S to G. So that's good. And for here, we now have to typecast it to controls dot access state. And hit save. So let's go ahead and test it out. So it's always a good habit whenever you make code to test it out to make sure there's no error messages. So we hit play. Now it remembers all of our different axes and displays it on the screen. How nice. Okay. So let's go ahead and cancel that. And let's go ahead and add in more things for the control. So now we need to be able to detect whether a button is on or not. So I'm going to say public bool is button on. So normally, if there's no return type, we would put void in the middle. Since we want to have a return type of whether the user presses the button or not, we're going to have the return type of Boolean in front. So what we're going to do is if, before we do that, one of our inputs we want to do is say button actions action. So this way we could easily define which action we're looking for and whether that action is actually pressed. So now when we do the definition, we're going to do if button parentheses int action dot access state equals to access state dot none. So if the button doesn't have an access state, we could assume that the button was configured for a key press. And if it is configured for a key press, we're going to do the very simple thing. If input dot get key parentheses button int action dot key, we're going to say the key is true. Oh, I forgot. We need to do return true. Okay, so just like the car moves, we do the input.getKey and button action.key. So only if we press the action key does this return true. Now we have to detect whether or not we press an axis. So if we didn't configure it for a button press, then it must be one of the analog stick axes. So we're going to define the second part. So if input dot get access is going to be button int action dot access greater than 0.1. So this detects whether the user pressed the joystick in the positive direction. But what happens if we map the controls to the negative one? So let's say we detect for the positive value, but the user mapped it to the negative value. We don't want the controls to do anything at this point because it was mapped to the negative value, not the positive. So we have to detect which value the user mapped it to. So we're going to say if button int action dot access state equals access state dot positive. Then we want it to do something. We're going to say return true. And we're going to copy this and paste it below, because this is going to be very similar to when we detect the negative value. So we're going to change this to less than negative 0.1. I'm going to change this to negative as well. So now we're able to detect the negative value. And finally, if the user didn't press any button, we're going to say return false. So the top part detects whether or not we press an actual button. And if we did press the button, then we're going to return true. The next one is going to detect a different axis. And if you press the axis, it's going to return true. Otherwise, we're going to return false. So we're going to hit save. Next, we're going to change the car moves. And we're going to get rid of this beginning part because we don't need it. And we're going to say dot is button on. And we're going to use parentheses this time. So delete all of this, and there you go. So car controls if is button on controls dot button actions dot up do something. So we're going to copy this portion and paste it on for the other 4 controls. Paste. Delete all this. Paste. Delete this. I'm going to copy this. Paste. Delete these. And finally, oops, paste and delete those. And hit save. Now let's go ahead and check it out, see if it works. So we hit play. These are our button configuration. So let's go ahead and go to our car prototype. And now, yay! Our cube is moving correctly. Now let's try to turn on the NOS. Oh wow, if you look on the top right, you actually see that the NOS is on, well, the NOS is flickering on and off. This sort of isn't good. So let's go ahead and correct that. So if we go to our config, not to our config, let's go to our controls. So the way we the way we solved this was we got a variable that said get key down. Well, that doesn't quite work out for the different axes. So what we're going to do is we're going to add in more information to our button info. And we want to create something that says button bool is on. And the whole point of the is on is to detect whether or not the button is on and only do the action only one time. So we're just going to copy the is button on function and we're going to paste it below. And I don't know, I just like to have clean code, so I'm just going to I'm just going to delete the spaces so I could have my curly brackets formatted correctly. Okay, all done. So I want to create my button to be is button down on. So what I'm going to do is say this. I'm just going to copy my button and I'm say button into action dot is on equals true. Okay, so the whole point of this is if the button is on, we're going to set it to true, and then we're going to return true. But let's go ahead and do a little test at the beginning. We only want to return true if this is the first time the button is pressed. So we're going to say if button action is not on, then we're going to recognize it as the button should be pressed. Otherwise, the button should not be pressed. Return false. Okay, so let's close that. Turn it on. Oh. So what does this mean? This means if the button is pressed initially, then to detect it. Else, if the button has been detected the first time and is still being held down, don't read it the second, third, fourth, or fifth time until the button is let go. So that's what these two lines mean. So we're going to copy this lines, and we're going to paste it on the next one. Paste and paste. And then once again, we're going to clean up the formatting. Okay. And finally, if the button is let go, then we're going to make it false. Okay? So if a button is pressed, we're going to detect it true for when it's pressed the first time, but false if it's being held down. And finally, if no button's pressed, we're just going to say button on is going to be false. And we're going to hit save. So let's go ahead and go back to car move. So we know for NAS toggle, we're just going to make this is button down on and hit save. So let's go ahead and play. And now let's go ahead and go to our car prototype. And yeah, we're moving around. So let's see what happens if I press my right analog stick and I hold it up. Wow, so now my NAS is on, it's not toggling off and on, or on and off now. So if I let go and I press it again, it's now off. So it makes toggling things on and off a whole lot easier. Wonderful. So next, we want to detect whether or not the user is pressing the analog stick just a little bit versus a lot. So if the user presses the analog stick all the way, the cube should move really, really, really fast. And if the user presses the analog stick just a little bit, it should only move a little bit too. So let's go ahead and detect whether or not the user presses the analog stick just a little bit or a whole lot. So we're going to go down and we're going to say public float get access and button action action. And the reason why we're going to detect the float is because and the reason why we're going to detect the float is because we know that the axis can either be a number between 0 and 1. So since those numbers are going to be a decimal point number, it has to be a float. So what we're going to do is if button int action is equal to axis state dot none we're going to say if if button action state dot axis state equals axis state dot none, and if input dot get key button int action dot key we're going to say return 1F. Okay, so what this does is, let's say the user presses like the A button or B button. Well, since the button only has an on and off switch, we want to return a value of 1 if it's true. And that's the point of the first code. What the F means is it converts the number that we put in into a float, because our return type is float. If we just say return 1, we might get an error message at the bottom. Oh, I guess we don't. Okay. I guess I'll leave it as 1 then. Okay, so now let's go ahead and detect the axes. So we're going to say else if input dot get axis. Let's type another letter. Button int action dot axis. Oops. Greater than 0.1. Okay, and I have a lot of typos. So let's go ahead and get rid of the extra int that I wrote in by accident. So yeah. If you go ahead and press the analog stick in a positive direction, we now have to make sure that we mapped it to the positive direction and not to the negative direction. So we have to say if button int action dot axis state equals axis state dot positive. Then we wanted to return our value of the axis. Well, actually, instead of 0.1, we actually want to do a value of 0 because we don't want to introduce a dead zone into here. So we're just going to do 0 instead. Let's see. And yeah, that is it. So here, why do I have... I forgot to close parentheses. So let's go ahead and close our parentheses here. So that little red squiggly line is an indication that something was spelled wrong. So now we're going to copy this, and as you guessed it, we're going to do it for the negative values. So if it's less than 0 and it's negative, then we're going to return this value times -1. So the whole point of the -1 is if the value is negative, we want to normalize it because we want it to be a value between 0 and 1. It's a good idea to normalize variables so that if the user remaps things backwards, they can still play the game. And maybe they prefer to map it backwards. And finally, if nothing was pressed by the user, we have to return something, so we're going to return 0 for if a button is not pressed. And let's go ahead and save that. Finally, under our car move, we want to have our speed changed based on how far we press the button. So it's going to be very similar to this. So we're going to copy this and paste it. And instead of is button on, we're going to say dot get axis. So we're just going to take this last part and copy it down for the other 4 things. So that's up, down, left, and right. And let's go ahead and hit save and test out our controls. So we hit play. So you go to our car prototype. Now if we move the joystick just a tiny bit, our cube is moving just a tiny bit. And if we press the joystick all the way, it doesn't really go fast because my NOS is off. So let's go ahead and turn NOS on. Okay, now let's move the joystick just a little bit. It's moving slowly. And now let's see what happens if we press the joystick all the way. Whoa, it's moving a whole lot faster. So that's how you read the different degrees of how far the analog stick is being pressed. And just make sure you go in all directions. And here, if we go back to our configuration, the whole point of normalizing data is so that we could map things backwards. So let's just say I want my up to be down on the analog stick, and my down to be up on the analog stick. My left could be right, and my right could be left. And now if we play, well, yeah, this should still work, even if you remap the controls backwards. And the benefit of this is now we can also detect whether or not we map the up, down, left, and right to buttons instead. And maybe my NOS is up on the analog stick, and our game will still work. Now if you use your buttons, the car could go left, right, up, and down. And if I press up on the analog stick, whoa! But yeah, it gives the user the freedom of mapping movements to button presses if they choose to, and also to map what you think should be button presses to an axis so that they can control their game to their preference. And there you have it. So if you like what you see, like, subscribe. If you have any questions, send a comment. But until next time, have fun and keep on creating games.